All right, guys, we're going to do 5.3 parabolas. Now, I apologize now. This one will probably be long, and I'm probably going to slow down even more the way I talk to give you guys time to think. So everything we're learning in this section is actually from secondary 2 curriculum, but this is the chapter that nobody ever gets to. So for all of you, this is brand new, okay? So we've already learned the graph of a quadratic function, which is f of x equals ax squared plus bx plus c, a not equal to 0. Because if a wasn't equal to 0, we would have a linear equation, okay? So that is called a parabola. We may also define parabolas in terms of distance, okay? So let's look at this definition. Let f be a point in the plane and let d be a line not containing f. So d right here. A parabola is the set of all points equidistant for f and d. Okay, so in other words, this distance right here is the same as that distance. Okay, the point f is called the focus of the parabola, and the line d is called the directrix of the parabola. Okay. Each dashed line from the point F to the point on the curve has the same length as the dashed line from the point of the curve to line D. So exactly what I highlighted. The point suggestively labeled V is, as we should expect, the vertex. The vertex is the point on the parabola closest to the focus. So the vertex is the closest to the focus. All right, so let's just look at how this looks. So the equation of a vertical parabola with vertex 0, 0. The focal length of a parabola is the absolute value of p. That is the distance from the vertex to the focus and from the vertex to the directrix. Okay, what does that mean? The focus is p away, absolute value of p. This would be your focus. Now, because the directrix is the same distance away from the curve as the curve is from the focus, that also means that this length right here is p. Okay? So that's the idea of the setup there. Let's go on to the next page. Equation 5.2, the standard equation of a vertical parabola with vertex 0, 0. Okay, so you got to kind of think of this a new equation for a parabola. Okay, kind of the same thing, but just a little bit different. The equation of a vertical parabola with vertex 0, 0 and the focal length p is x squared equals 4py. Okay, so anytime you see it in this form, this is a parabola. Now, we know it's a vertical because it's x squared. And then if p is greater than 0, it opens up. Right? It's upward. Whereas if p is less than 0, we go down. Okay? Notice that the standard equation of a parabola above, only one of the variables, x is squared. I pointed it out. This is a quick way to distinguish an equation of a parabola from that of a circle. Because remember, the circle, what we learned last time, was that the x and y were squared. All right, so also keep in mind right now we are doing examples where the vertex is 0, 0. Okay. All right. Example 1, graph the parabola given by the equation x squared equals negative 6y. Find the focus and the directrix. Okay, so first of all, let's point out that the vertex is 0, 0. I want you guys to keep in mind that we are talking about x squared equals 4py. And remember that the focus is p, the absolute value of p is the focus. So knowing that, we now can solve for the focus. So if you look here, in our equation, we have x squared equals negative 6y. So to find the focus, negative 6 equals 4p. Now we're going to solve for p. We divide both sides by 4 and reduce it, and we get negative 3 halves. Now, let's keep in mind that since p is less than 0, it is a downward parabola. And I know because the vertex is at 0, 0, the foci is negative 3 halves away. So that means the foci, or the focus, is at 0, negative 3 halves. This would change if the vertex were a little bit different. So I can go, that's 1, negative 3 halves right there. Okay. And then remember that the directrix is the same distance away. I can't spell this, huh? Dirt. Okay, directrix is the same distance away. So the directrix would be 3 halves. Now let's keep in mind that the directrix is a line. So the directrix is equal to y equals 3 halves because it's on the other side. So the directrix is this line. The vertex is here, the foci is here, and then we know that we open this way. Now, here's our problem. I just made a parabola, but do we know it's the exact one we need? No, because I could have made one skinnier. I could have made one a little bit wider. So how would we know this? Well, let's talk about the lattice rectum. So of all the information requested in the previous example, only the vertex is part of the graph of the parabola. Okay, only the vertex works. So in order to get sense of the actual shape, we need more information, and that's what the lattice rectum is. So the lattice rectum shows you the distance between the curve that goes through the focus. So don't forget, it has to go through the focus. And if you realize that this side is, of course, going to be the same distance as this side. That makes sense for a parabola, right? So how do we find that? Well, the focal diameter, or the lattice rectum, is the absolute value of 4p. So this distance is going to be the absolute value of 4p. And then we're able to cut it in half if we need to, find those 2 points, and our parabola is more than perfect. Okay. All right. So let's look at what we're going to do when we start graphing and everything. The following diagram summarizes the key features of a parabola. So these are the things that we're going to need to know when we graph. We're going to need to know the vertex. The vertex is going to help us with the axis of symmetry. Remember, that's when it reflects on itself. We have the distance of the focus. So the focus is important because that also helps us where the directrix is. And then we need a lattice rectum, which helps us make our parabola where it needs to be for the narrow or the wide. Okay, so next, as you can see, we were talking about before a vertical parabola. But with that, we could do a horizontal. Same idea. The difference is here, if you look down below, we have y squared. So when y squared equals 4px, we have our horizontal. Now be careful with that, because that means the directrix now is a vertical line, which is x equals, and we talk about left or right. So we talk about that when p is greater than 0, it opens to the right. P is less than 0, it opens to the left. Again, the vertex is great, but that doesn't tell us where it opens. So we need to know what direction it goes in. So let's start practicing some of that stuff. Okay. All right, and I think what I might want to do is use some color here, so that way you can see what it looks like after I do the work. All right, so first of all here, I have a y squared equals 12x. So right away, I know I'm dealing with a horizontal, okay? I also want to keep in mind, and I'm going to write it again, but eventually you won't have to do that. This is 4px, right? So that means my 4p equals the value of 12. So when I solve for that, that tells me that p equals 3. So what does that go from there? Well, if 3 is greater than 0, that means it opens right. Okay, the other thing I want you to keep in mind is that this is in the form y squared equals 4px, so that means the vertex is 0, 0. Okay, so I'm going to start graphing these as we solve and go further. So the vertex is 0, 0. The foci is 3, which means it's going to open right. So I have to go to the right. The foci is 3 away from the vertex. So there's the foci, and I'm going to write that down just in case I ever need to write it as a coordinate pair. Whew. Now, keep in mind, even though it's a coordinate pair, it is x comma y. So it is 3, 0. Okay. Well, if the focus is 3 away, so is the directrix. So directrix, okay. So the directrix is 3 in the opposite direction. So 1, 2, 3. And as you can see, the directrix is, in this case, a vertical line. Well, if I had to write what that vertical line is, it's x equals -3. Okay, that's good. So far, so good. We did the focus, we did the directrix, but now we need the endpoints, so that way we can get our correct parabola. Okay, now let's keep in mind what we did on the other side. It said that the focal diameter, which is the lattice rectum. Let me write that down. Is the absolute value of 4p equals, and then of course 4p is 12, right? Well, that's the great thing about having the equation set up like this. Now, it's not always going to work that way. You'll see as we get to problems ahead. So the diameter is 12. Well, what does that mean? That means we're 12 wide. So think about splitting it in half. That means 6, right? So it goes through the focus. So the focus is here. So 1, 2, 3, 4, 5, 6 on that side. 1, 2, 3, 4, 5, 6 on that side. And now we can make our parabola. Now, in case our problem needs it, and I actually have to say those 2 points, because it wants the endpoints there. Well, now I can say, well, that is at the point 3, 6, and the other one is 3, -6. Okay? All right, well, we know that our vertex is not always going to be 0, 0, so we have to play around with that. The equation of a parabola with vertex HK. Remember, we're talking about opposite. So this is the form we're going to be in. So vertical, of course, has our x squared. Horizontal is our y squared. Same thing with opening up, up, down, left, or right, okay? All right, so let's see what we have so far. First thing I want to point out is the vertex. So vertex, remember it's HK, so opposite. So -1, 3. I'm going to graph things as I go, so that way I'm not trying to throw everything together. So -1, 3. I also want to write down and remind myself this is kind of a x squared, okay? Oops. So it's a vertical. So it's either going to open up or open down, okay? Keep that in mind as we go. Next thing I want to keep in mind here, 4p is what's on the in front of the parenthesis there. So I can say that 4p equals 8. So when I solve, p equals 2. Now, because it's greater than 0, it opens up. So I'm going to go up 2 from the vertex. Now that tells me that the focus is at the point -1, count it up, 5. Okay. Well, if we know the focus is up 2, then the directrix is down 2. And remember, the directrix is a line. I'm going to put that in. And now I can actually write that down. The directrix, and this is a horizontal line, so it's y equals, and it looks like it's at 1. Okay, so far so good. What's left? Well, we need to find the length of the lattice rectum, okay? Remember, that's the absolute value of 4p. Well, luckily for us, it goes straight down to that 8. So the lattice rectum is 8. If I want to think about it as 4 away. Okay, so I'm going to count 4 from the focus, not the vertex, the focus. So 1, 2, 3, 4. And on the other side, 1, 2, 3, 4. So if I were to graph it, we're good. And of course, I need to write down those coordinate pairs. So this is 1, 2, 3, 4, 5. So we have -5, 5. And the other endpoint is at 3, 5. And we're done. Okay. Keep going. All right. What happens now? Find the standard form with the parabola of the focus 2, 1 and directrix of y equals -4. So there's not much information given to me. The first thing I actually want to do is I want to see what this looks like. So I am going to make a graph. and plug in these values, okay? So the focus is at 2, 1, okay? The directrix is at -4. And it's y equals, so it's a horizontal line. So let's talk about what's given to us. Well, first of all, since the directrix is a horizontal line, we are talking about a vertical parabola. So that means our x squared, right? And then we need to talk about that the vertex is halfway. So vertex is halfway between the focus and the directrix, okay? So let's talk about that then, okay? Well, if I were to do halfway, right, I would say that, let's see, that's 5. What's half of 5? 2.5. So if I go 1, 2, I'm right here. Let's keep in mind then that the vertex is at the point 2, and that is at -3/2. Okay, if you have to see that again, it's knowing that, let's see if I can get a pencil or something. Okay. This distance here is the same as this distance here, which is both 2.5. Those are just some little notes, okay? Once I find the vertex, I can actually now start writing in our standard form. So we have to remember it's x squared. So we have x opposite, right? So -2 squared equals, now be careful, we're going to fill this out because it's the 4p stuff, right? Y, and then opposite, so +3/2. Okay, now we still have to do the 4p, right? Well, let's think about this. Remember, p is the distance from the vertex to the foci, which means, remember, it's 2.5, so 5/2. So p equals 5/2. If you remember the standard equation, and I can show you back here, I'm going to go back here, is 4p, right? Well, if p is 5/2, we think of it as 4 times 5/2. Now, of course, if we have a multiple choice question, you're not going to see 4 times 5/2. You're actually going to do that multiplication now. So our final answer is x minus 2 squared equals 10 times y plus 3/2. Okay. All right. Of course, we can get more complicated. Because what about if we have an equation, but we have to write it in standard form before we're able to graph? Okay, it would be nice if it's always in standard form, but we know from even the circles that we don't always get things in standard form. So how do we do that? Well, we're going to have to complete the square. What I want you to notice in example 5 is that y is squared. So we're talking about a horizontal parabola. Okay, so the first thing we're going to do is get all of our y's on one side and all of our x's on the other. Now that constant there goes on the side without the square. So first thing I'm going to do is move that 8x over to the other side. And I'm going to put the 8x in front, okay? So negative 8x plus 4. All right, next thing I'm going to do, remember standard form means that we have that first, or that left side being squared. So we have to complete that square to get it to be a perfect square. Remember how we did that? We take our b divided by 2 and square it. Well, 4 divided by 2 is 2. 2 squared is 4. So y squared plus 4y. So we're going to add the 4 in. We know even from reviewing with circles, whatever we do to one side, we must do to the other. So what I'm going to do here, guys, is I'm going to underline this so you realize we added that in. Okay. All right. Next step. Well, this is our perfect square. We have a y plus 2 squared. Remember, this value is just b over 2. Okay. Here, if you look at this, guys, now we have this negative 8x plus 8. Okay, so far so good. We've got the left side looking the way it is. But if you remember, on the right side here, we need to make it look like 4p times the parentheses, right? So what do you know? What's common on the right side here? Well, that 8, and let's do the negative 8, because this is usually a positive x. It has to be positive there. So we get negative 8 times, and that would be x minus 1. And now we have our standard form. Now we can create everything else. Okay, right from here, we can do our vertex. So our vertex is, excuse me, don't forget it's x comma y. So in this case, it's 1 comma negative 2. Okay, I'm gonna right away graph that. 1 negative 2. Okay, so that's the vertex. Now we also want to keep in mind that p, right? So 4p equals negative 8. So when we solve, we get p equals negative 2. Okay, and that means since it's less than 0, it opens to the left, and it's 2 away. So I'm going to go to the left, 2 away. So 1, 2. All right, that means that the focus look at that coordinate. That's negative 1, negative 2. All right, let's look at the directrix. It's the same distance, but the opposite way. So 2 there, and this is a line. Let's keep in mind it's a vertical line. So directrix is x equals, and it looks like it's 3. All right, now let's keep in mind that our lattice rectum, right, that diameter is the absolute value of 4p, which of course is just this front part here, which is 8, right? It's absolute value, so it's 8. You could say negative 8, but again, absolute value. Remember, think of dividing it in half. So it's 4 away from the focus. So here's the focus, 1, 2, 3, 4. 1, 2, 3, 4. Okay, and then if it wanted the endpoints, we could just mark those points on. But according to this equation, or this question, we just need the vertex of focus and the directrix. All right, a little bit more. Sorry, guys. We gotta see how we can use this in real life situations. Okay. So in studying quadratic functions, we have seen parabolas used to model physical phenomena such as trajectories of projectiles. Other applications of parabolas concern its reflecting property and necessities, knowing about the focus in the parabola. Okay, so one of the things where we see something like this is a satellite, right? It's the parabola shape, almost like that bowl. Okay, so they did a slight illustration of it, and you can see the parabola as is. Okay, so let's see what we can do with it. A satellite dish is to be constructed in the shape of a parabola if the receiver placed at the focus is located 2 feet above the vertex of the dish, and the dish is to be 12 feet wide. How deep will the dish be? Okay, what is that saying? Let's draw it out. Well, first of all, to make this simplistic, okay, just so it makes it easier to calculate everything, okay, we're going to make the vertex at 0, 0, and that is okay to do. So the vertex is at 0, 0, and I'm just going to draw a parabola, okay. We then know the focus is a receiver, right? That is 2 feet above the vertex. Okay, so that's where our dish goes to. Now, or not our dish, our receiver. Now, here's the thing. Of course, a parabola goes on forever, but because we're talking about a real or a satellite, it doesn't go on forever, right? A satellite doesn't go on forever. So actually, what's happening is at the end of our parabola here, we know that this is 12 feet, which of course, because we are dealing with the vertex being at 0, 0, one side is 6 and the other side is 6, okay? Now, it is a vertical parabola, so we know that we're dealing with x squared, and that equals 4p y. All right, so what happens here? Well, first of all, I know that p equals 2, because that's where the focus is at. So right now, if I plug that 2 in, I get x squared equals 8y. So first of all, that's the equation we're working with. Now, where can we go from here? Well, I know that there is a coordinate pair right here at the very end, right? The very end. I know that this is the value of 6, right? The x value of 6. My question is asking, how deep will the dish be? So what I'm actually trying to find out is, what is this distance right here? So at the end, what is that distance? Because that tells us how deep the dish is. Does that make sense? Okay. So remember, we know the x value is 6. We're trying to find the y value. Well, the great thing is if we have an equation and we have one of the variables, we can solve for the other one. So let's substitute in. We get 6 squared equals 8 times y. 36 equals 8y. And then when you divide through, we get that y equals 4.5. So we know, oops, it's about to write the unit, 4.5. So we know that the dish, so the dish is 4.5 feet deep. kind of crazy. Okay, let's see what else we can do this with. A cross-section of a design for a travel-size solar fire starter is shown. Okay, so let's just see. So we have a depth. By the way, this is not the Directrix. Look, this is from end to end. It's 4.5. The igniter is 1.7 away. Okay, so that's what I'm seeing. We're going to, again, stick with simplicity because this allows us that if this is at 0, 0, I know that each of these distances is 2.25, right? And then cut this in half if this is at 0, 0. Okay, just makes it easier for a calculation. The sun rays reflects off the parabolic mirror toward the object attached to the igniter. Because the igniter is located at the focus of the parabola, the reflection rays cause the object to burn in just seconds. Use the dimensions provided in the figure to determine the depth of the starter. Okay, here we go. So let's keep in mind this is a vertical again, so we're dealing with x squared equals 4py. Okay, we know that P is the 1.74. Not 1.74, 1.7. Sorry, guys. Excuse me. Okay, when I calculate that out, that gets me x squared equals 6.8y. Again, so I'm trying to find the depth, which means I'm trying to find that value. Well, just like we did on the satellite one up here, this is our x value. We're trying to find our y value, so I can plug in our x value and solve for our y. So when we do this, we get that y is approximately 0.74. And then let's talk about units. So inches deep. Now, again, just remember when it comes to the applications, guys, simplify it. Make the vertex 0, 0 if you can. That makes all your calculations easier to deal with. All right, try some of this out. If you have any questions, make sure you're asking.